Okay, by request, we're going to graph f at x equals x plus 2 over x minus 3 and state any features of this graph. Okay, to get started, we're going to find the domain and the range here. The domain is that x is not equal to 3. Here's how we know. If x was equal to 3, you would have 3 minus 3, which is 0 on the bottom. You absolutely cannot divide by 0, so x equals 3 is not in the domain. However, any other real number, so that aside, x could be any real number, because any other real number, you could add 2 to it, subtract 3 from it, and then calculate the fraction. The range is that y is never equal to 1. Now, if you're curious as to why, that'll be better explained when we look at end behavior. So I can leave the reason why for now. Perhaps you could come back and answer this at the very end, if that's not obvious from looking at this. Okay, and your asymptotes. You have two asymptotes here. One of them is y is equal to 1, and I'm going to clarify that when we look at end behavior. And the other one is we have a vertical asymptote at x equals 3. And the reason why is this. As soon as you have a restriction, you have a value such as 3 that x cannot be equal to figure out what's going on, you can put in values somewhere near that. So, for example, you could put in f at x, let's say f at 2.9. And f at 2.9 is 2.9 plus 2 over 2.9 minus 3. And that gives us 4.9 over 0.1, negative 0.1, which is 49. And what you will find is as you put in numbers that get closer and closer to 3, you will get larger and larger numbers. That indicates to you that you have an asymptote at that point. Our x-intercept, to find the x-intercept, you simply make y equal to 0. So again, if f at x is equal to x plus 2 over x minus 3, and we're looking for the x-intercept, we want to find the spot where all of that is equal to 0. At a glance, you can tell this is a negative 2. If you want to do the algebra, multiply out 0 times x minus 3 is equal to x plus 2. X is equal to negative 2. So that's our x-intercept. And then the y-intercept. Remember, that is the point, the y-intercept is the point here where x is equal to 0. So somewhere along here where x is equal to 0. Since we're in Lagrange notation, we only need to just evaluate f at 0. So that's 0 plus 2 over 0 minus 3. That's negative 2 over 3. So to recap, we have so far a domain that x is not equal to 3, a range that y is never 1, a horizontal asymptote where y is equal to 1, and a vertical asymptote where x is equal to 3. Now we know that this is an asymptote because we plugged in values close to 3 and start finding really large values show up. So what you're going to find is the closer you get to 3, let me do one more just to make that perfectly clear. I'll put in, say, f at 3.001, and we're going to get 3.001 plus 2 over 3.001 minus 3. And that gives us 5.001 divided by 0.001, which means times 1,000. So that's going to give us 5,001. So as you can see, the closer you get to that point 3, the larger these numbers are. You try and put in the number 3 exactly, you end up dividing by 0. So that's a value you clearly can't find because it's not defined. Okay, now we're going to look at end behavior. So we want to try and figure out what happens to our function as x goes to infinity. So as x approaches infinity, all we need to do is put in really large values to try and figure out the pattern. So as x gets large, let's say we were to put in, we'll put in a couple, we'll put in 100 and 1,000. So if we put in 100, we get 100 plus 2 over 100 minus 3, which is 102 over 97. And 102 over 97 is 1.05. Now let's put in 1,000. If we put in 1,000, we get 1,002 over 997. Which is 1.005. And the larger the number is that we put in here, the closer and closer we get to 1. So that gives us this end behavior. As x approaches infinity, f at x approaches 1. And we can further clarify. See how we have numbers above 1 that get closer and closer to 1? As x approaches infinity, f at x approaches 1 from above. Likewise, as x approaches negative infinity, f at x, I'll let you put in your own large negative values to verify this for yourself. As x approaches negative infinity, f at x approaches 1, but it approaches it from below. I'll put in one value to illustrate this point. If we put in f at negative 100, we get negative 100 plus 2 divided by negative 100 minus 3. That gives us negative 98 over negative 103, which is a positive 0.95. And the larger the number the larger the negative, I should say negative of greater magnitude, the bigger the negative that we put in, the closer and closer we get to 1, but we're always approaching from underneath. It'll become 0.95, 0.99, 0.999, and so on. So that's approaching 1 from below. I'm going to summarize all of the key features and then draw the graph. So given that f at x is equal to x plus 2 over x minus 3, we have a domain that x is never equal to 3, so that we don't divide by 0. We have a range where y is never equal to 1 because there's no value we can put in that'll make it equal to 1. However, we get arbitrarily close to it. we have asymptotes. There's a vertical one at x equals 3 and a horizontal asymptote at y equals 1. We got this from plugging in points near that forbidden value of 3 and seeing that they blew up. And we got this for putting in large x values and see that as x gets large, y approaches 1. Finally, we also have an x-intercept that we calculated to be -2. And we have a y-intercept that we calculated to be -2/3. So you can just pause that, write it down, and then I'll show you how to take all of this information and draw your graph. Okay, so I'm going to put all the information in. We've got an asymptote at x equals 3, so I'll draw that in with a dotted line where x is equal to 3. We've got a horizontal asymptote where y is equal to 1. I'll draw that in here. We also have an x-intercept at -2. And we have a y-intercept at -2/3. Now with our end behavior, as x approaches -infinity, we approach 1 from below. And you can see we're heading towards our asymptote at 3, where we're going to, our y value is going to -infinity. Over on the other side, our end behavior is as x approaches infinity, y approaches 1 from above. And we're staying above this line, coming in at our asymptote, it's going to go up. So that is f at x equals x plus 2 over x minus 3.